where learning never stops. Good afternoon, Ortanistas. Good afternoon, grade 10 students. Welcome once again to week 6 of quarter 2 of grade 10 science. Only here at Science Matters, where learning never stops. Happy New Year sa inyong lahat. Kamusta kayo? Welcome sa ating first synchronous class for this year, 2022. I hope you are all excited. Sige, magkamustahan muna tayo. Gusto kong mabati rin yung mga kanina pang mga nakatune in sa ating live streaming this afternoon. Babanggit ko lang yung mga pangalan nila. Kay Mary Ann, good afternoon from Aquino. Kay Ryan, from Aquino rin siya. Kay Gerald na from grade 10 Sakay, hello. Kay Krishmela from grade 10 Aquino rin. Ang sipag ng Aquino ngayon in fairness. Kay Charlie from Aguinaldo. Of course, from Mary Ann, Happy New Year din sa'yo. Kay Jiro, good afternoon. Kay Casey from Quezon. Kay Raika, kay Imerson. Ayan, meron pang happy si Imerson. New Year pa rin. Alaysa. Ayan, Happy New Year din, sabi niya. Kay Don Marvin from 10 Ponce. Ayan. Kay Justine. Ayan, Happy New Year din daw. Erica and Krishmela. Ayan, Erica from 10 Rizal. Ayan, at yung iba pang mga MDL students natin na hindi pa nakatune in ngayon, kung kilala nyo sila, isend nyo na yung link na mga nasinend ko sa inyo para dito sa ating synchronous class for this afternoon. Kasi I really want na maging excited kayo because bago yung lesson natin this afternoon. At ayan nga, siguro habang inintay ko rin na mag-comment kayo ng emoticon of your choice, I believe the screen is showing you different emoticons of how you're feeling this afternoon. Ayan, may mga nagko-comment na, si Charlie masaya, I mean excited, si Krishmela din, si Mary Ann, si Raika, si Jared, they're all excited, and I hope you are all excited because bago nga yung lesson natin this afternoon, hindi ko na patatagalin pa. Our most essential learning competency is to predict the qualitative characteristics. And when we say qualitative characteristics, these are the orientation, type, magnification, etc. of images formed by plane and curve mirrors and lenses. But this most essential learning competency is actually good for 2 weeks. That is why for this week, week 6, mag-focus muna tayo sa mirrors at yung lenses na nabanggit dyan sa huling part ng ating milk ay didiscuss naman natin next week. Alright? And so with that, our lesson for today, sabi nga sa aking thumbnail kanina, it's all about mirrors or the qualitative characteristics of plane and curved mirrors. But our focus is all about mirrors for this afternoon. And I hope you're all excited. Good afternoon din daw. Sabi ni Krishaline, ayan, ni Giselle, tama ba? Ni Erica from, ayan, Giselle from Tenabad Santos. Si Erica ay student ni Ma'am Grace. Ayan, ang mga teachers nyo sa grade 10 science ay nanonood din ngayon. Kaya ayan, keep on commenting din. Samantha from 10 Sakay. Feeling ko po ngayon kulang po ang Christmas break. Ayan, sabi ni Justine. Ayan, siguro lahat tayo ganun yung feeling, no? Pero, wag natin i-entertainin yung ganong feeling. Instead, let us be excited kasi bagong taon, bagong lesson, and I hope marami kayo matutunan this afternoon. And of course, kay Hazel Ann, good afternoon din from 10 Rizal, and kay Faith, and of course, sa lahat ng mga, of course, grade 10 science teachers na nakatune in ngayon, nanonood sila, so mag-comment kayo. At sa lahat ng grade science teachers po dito sa ating school, Dasmariñas North National High School, na mga nakatune in din ngayon this afternoon. Good afternoon po sa inyong lahat and Happy New Year po sa inyo. Ayan, so I hope hindi rin kayo masyadong naglalalabas because we are on alert level 3. Okay, so pero kaya kahit ganoon, class, patuloy pa rin yung sync natin, hindi po mawawala. Every week pa rin po tayo magkakaroon ng sync at hindi po matatapos yung pag-aaral. Sabi nga natin, here in Science Matters, learning never stops. Ayan. Ayan, good afternoon din sa'yo, Edward and Faith. Nabanggit ko na yata si Faith kanina. Ayan, Edward from 10 Rizal and Faith from 10 Sakay. Good afternoon din sa'yo dyan. Ayan, and with that, siguro simulan na natin yung lesson natin for this afternoon. Of course, we have this video lesson prepared to us by none other than my head teacher 1 of the Science Department, Sir Nicanor Reyes. Here we go.
Hello grade 10 students, it's me again, Sir Nick Reyes, and today we will be discussing about one of the properties of light, which is about reflection. So keep on watching and stick around. Only here at Science Matters, where learning never stops. Reflection is the bouncing of light. It is usually compared to a ball that is bouncing off the floor. When this ball strikes the floor at an angle, this ball bounces off at an angle as well, just like this. When light is incident on a surface, it is either transmitted, absorbed, or reflected. If you will observe closely, the angle at which the ball hits the floor is the same angle at which it bounced. The same is true with light, and we call this as the law of reflection. The law of reflection states that when an incident ray of light strikes a surface at an angle, it creates an angle of incidence with respect to the normal line. As it reflects, reflected ray of light will create an angle of reflection with respect to the normal line, and the angle of incidence is equal to the angle of reflection. This is a plane mirror. It is designed to create an image similar to the subject. As I look into the mirror, me and my image are of the same height. And also, my image is of the same distance as I am in front of the mirror. If you're going to look closely, it seems that everything around me looks exactly the same in front of the mirror, except for one. If I am going to raise my right hand in front of the mirror, the image is raising his left hand. And if I'm going to raise my left hand in front of the mirror, the image is raising his right hand. This is called lateral inversion. Not all mirrors are flat mirrors. There are curved mirrors. Probably you have already seen one but did not bother to investigate on it. These spherical mirrors are designed to create different kinds of images. So let us look at each kind of spherical mirrors one by one. Let us study first concave mirrors. Concave mirrors are designed to converge parallel incident ray of lights at a certain point. That is why it is also called as converging mirror. The point where parallel rays of light intersect is called focus. The distance from the focus to the mirror is called the focal length. The center of the curvature, or simply center, is a distance that is twice the focal length. We can use the points focus and center to locate the image formed by concave mirrors using ray diagram. This is a concave mirror. When you're looking at the reflection on the mirror, what you're seeing is a virtual image. That is the image that is formed at the back of the mirror. However, this concave mirror also produces a different type of image which we call a real image. That image cannot be seen on the mirror but instead can be projected on a screen. I'll show you an example. And I'm going to use this concave mirror and I'm going to project that tree into this wall that would produce a real image. So the image that you are seeing right now on the wall is an example of a real image. Today we're going to perform an experiment using this optical bench to locate the image formed by concave mirror. I have here a concave mirror with a focal length of 7.5 centimeters. And I'm going to use this candle that will serve as our object. And I have here a white screen to locate the image formed by this concave mirror. Alright, so today we're going to put the object beyond the center of curvature. Remember that this mirror has a focal length of 7.5 centimeters. So therefore, the center of curvature is placed exactly at 15 centimeters. So we're going to place the candle beyond 15 centimeters. So we place the mirror at the distance of 40 centimeters. And I'm going to place the object maybe at around 70 centimeters in the optical bench. Now we're going to use this white screen to locate the image formed by the mirror. Now let's try to find the sharpest image. Okay. So there you have it. Okay. So the object is placed at around 70 centimeters. The image is found at around 52.5 centimeters or 12.5 centimeters away from the mirror. So if we're going to describe the image now, we can see that the image is smaller as compared to the object. The image is also nearer to the mirror as compared to the object. The image is inverted, and the type of image is a real image because the image is formed in front of the mirror. Now we're going to place the object at exactly 15 centimeters away from the mirror or at the center of curvature. Now as you can see, the image is formed also exactly at the center of curvature. And if we're going to describe the image is almost of the same size as the object is. Our object is the flame of the candle. Now the image is inverted. As you can see, as I move this upward, the image moves downward. And if I'm going to move this downward, the object or the image moves upward. Now the image is also inverted, and it is a real image. Now what if we're going to place the object at a distance between F and C? Let's find out. So I'm going to place the object at a distance of around 50 centimeters from the mirror. And let's try to look for the sharpest image here. Okay. So as you observe, the image is formed farther from the mirror. The image is also appears larger as compared to the object. The image is still inverted, and it is a real image. Now, if we're going to place the object at exactly 7.5 centimeters or at the focus of the mirror, what do you think will be the image it will be? So as you can see, when the object is placed exactly at the focus, no image is formed. Now if we're going to place the object between the focus and the mirror itself, so meaning we're going to place the object at a distance less than 7.5 centimeters, what do you think will the image would appear on the mirror? Okay, so as we can see that the flame appears to be bigger or larger. It is also farther from the mirror. The image is already upright. And the image, since it is formed at the back of the mirror, therefore we can say that the image is a virtual image.
On the other hand, convex mirror scatters parallel rays of light when it strikes the reflecting surface. That is why it is called a diverging mirror. Unlike concave mirror, convex mirror have a virtual focus and a virtual center of curvature.
The image that you can see in this Christmas ball is similar to the image that you'll be seeing in a convex mirror. It is always smaller, nearer, upright, and virtual. This season has given us some time to rest and to reflect. And in one of my reflections, I remember one person saying, "With great power comes great responsibility." I am Sir Nick Reyes, and you're watching Science Matters, where learning never stops.
All right. Thank you so much once again, Sir Nick, for preparing that very informative, very good video lesson for us for this afternoon. Ayan, it's all about mirrors. At I hope na-appreciate nyo nag-experiment pa si Sir para sa atin. And to summarize all that he has discussed, ayan, so let us move on to our PowerPoint presentations. Of course, ang focus nga ng ating lesson for 2 weeks are all about mirrors and lenses, but for today we will just be discussing about mirrors. And sabi nga rin ni Sir Nick, dinedefine niya sa kanyang video kanina, no? Mirrors are polished or smooth surface that forms image. Paano? Sa papaanong paraan? Sa pamamagitan ng reflection. And reflection is actually a property of wave, okay, wherein the wave, specifically the light wave, bounces back, okay, as it hits that surface. So kaya daw tayo nakakita ng image. So tatanda natin yung mga binabanggit na mga terminologies ni Sir, no? Kasi matidiscuss din natin siya this afternoon sa ating summary. Yung ikaw na nasa harapan ng salamin, ang tawag sa iyo ay object. Anything that is in front of the mirror, we call it object. And the image that is formed, yun nga yung tawag natin, yung nakikita natin sa loob ng salamin, no? Yun yung tinatawag natin na image. Alright? And at nabuo yun sa pamamagitan nga ng reflection. At dinefine din ni Sir, no, yung law of reflection sa kanyang video kanina. That the angle of incident is always equal to the angle of reflection. Bakit ko kinuha yun? Alright? So we have 3 types of mirror. The first one is the plane mirror. And of course, we have the spherical mirrors that are the concave and the convex mirrors. Alright, so yung mga, ayan, bumapalakpak, no, napansin ko yung mga students natin. Sa mga humabol, maraming salamat sa inyo, kala Kenshin, Hazel, Ann, Zaira, Sofia, Raisa, Craig. At yung mga naka-appreciate ng ating video for this afternoon, sila Charlie, si Emerson, si Alex, si Edward, and si Erica. Ang galing talaga gumawa ng video ni Sir. And that is why, ayan nga, i-continue natin yung discussion natin sa ating lesson for this afternoon. So, let's summarize, no? Sabi dito, what are the characteristics of plane mirror? Discuss natin isa-isa yung mga mirrors na binanggit niya. So first, we have the plane mirror. At ang image nga na na-form dito ay virtual. So ibig sabihin, it appears to be at the back of the mirror or inside the mirror. Okay? Yung ibig sabihin ng salitang virtual. The image is laterally inverted na pinakita nga ni Sir Nick na whenever he raises his right hand dun sa image, left hand nung image yung nakikita natin na naka-raise. And meron tayong activity niya, no, both MDL and ODL, that you are going to perform that same thing in front of a plane mirror. So I think that's the first one na activity natin, both, no, sa MDL and ODL, na naka-open na sa ODL students natin sa LMS natin. The image is erect. When we say erect, it is upright also. So parehas lang yung term na yun na ginagamit natin. Ibig sabihin, hindi po nakabaliktad or hindi po inverted ang image na nakikita natin sa plane mirror. The size of the image is the same as the size of the object. So kung gaano ka katangkad, ganun din yung nakikita mong image. No? Ganun din siya katangkad sa mirror. Aside from yung hindi nga, kasi may mga mirror tayo na kahit plain siya, may mga sometimes distorted, no, kapag hindi mga original. Alright. And then the distance of the image obtained is the same as the distance of the object. So kung gaano kakalayo, if you're 1 meter away from the mirror, yung image na nakikita mo sa loob ng mirror ay 1 meter din away from dun sa mirror na yan. Okay, so dahil nga ganun ang binibigay sa atin ng plane mirror, so definitely equal lang, no, yung angle of incidence sa angle of reflection. So, equal lang din yung nakikita natin. So, ganyan yung mga rays na nire-represent natin dyan. Next is the convex mirror. So, yung convex mirror, hindi pala ako nakapagdala ng sample, no? So, yun nga yung parang pabuntis na ganyan na usually nakikita natin sa 7-Eleven. Okay? So, a convex mirror is also known as the diverging mirror. Okay? Because as the mirror diverges the light as they strike on its reflecting surface. It is virtual, ibig sabihin, it appears to be at the back of the mirror, it is erect, hindi rin siya baliktad, pero diminish yung image, ibig sabihin mas maliit. So kung mapapansin nyo, pag kayo tumingin dun sa mirror sa 7-Eleven, mas maliit kayo, hindi kayo kasing size nung nakikita nyong image, no? Hindi nyo kasing size yung image nyo na nakikita dun sa mirror yan. Irrespective of the distance between the object and the mirror. So pag nag-strike yung light ray na ganyan sa convex mirror, magda-diverge siya na ganyan. That is why it is also known as diverging mirror. So the light rays will diverge that way. Okay? What about the concave mirror? So ang concave mirror naman, it converges light to a point. So kaya converging mirror naman ang tawag natin sa concave mirror. When an object is very close, magnified and virtual image is obtained. Ibig sabihin, magnified, mas malaki. And it appears to be at the back of the mirror, so it is virtual. If we increase the distance, so kung lumalayo daw tayo, yung object, no, or kung ikaw man yung object, kung lumalayo ka dun sa concave mirror, yung size mo ay nare-reduce and real image is also formed. So pag nag-strike ang light ray sa concave mirror, ayan, magko-converge siya into a point. That is why it is called converging mirror. Concave mirror, converging mirror, and convex mirror is diverging mirror. Mas magandang maintindihan niyo yan at maalala niyo because next week, sa lenses, babaliktad na yan. Alright? And so, meron tayong isang mabigat-bigat na activity, no? Are you lost after reflection? So, lost stands for location of the image, for L. O is orientation of the image. S is for the size of the image, and T is for the type of the image. Now, sa ODL students, talagang may nakalagay na ganyang activity sa bandang engagement part. Sa MDL, hindi po, no? Ganito ang ginawa ko po dyan, class. Kasi we have mirrors and lenses, right? Sa lenses, meron kayong activity na parang ganito, are you lost after refraction? Pero wala kayong activity ni are you lost after reflection. Pero wala man kayo nun, ang dami-dami ng mga activities nyo. I think mga learning task hanggang 8 ang meron tayo sa MDL in comparison with the ODL students na parang 4 lang ang mga, or 3 lang inopen ko sa kanila, although mahaba yung iba. That is why, yung mga MDL na hawak ko, papalitan ko yung learning task 5, 6, 7, 8 na napakahaba into something like this para parehas kayo ng gagawin ng ODL. Kasi ganito rin naman yung gagawin yung lahat next week when it comes to lenses. So, you will be having this type of table, no? Magbababa ako ng ganitong table, and then you will be answering ano ang location, orientation, size, and type ng image if the object is placed at number 1, beyond C, number 2, at C, number 3, between C and F. Actually, in the video kanina, ipinakita ni Sir, inisa-isa niya yon. Alright? Na tunay, kasi talagang experiment yung pinerform niya. So, para sa mga hindi nakaabot masyado dun sa video natin kanina, although pwede nyo namang balikan, I have prepared here yung ray diagramming kung paano natin mapapatunayan lahat ng mga sinabi ni Sir sa video kanina. So, we'll start with the concave. We'll focus on the concave mirror first. So, we have the concave mirror right here. Alright, and we have here the principal axis. Tawag natin sa line na yan, principal axis. And then we have here the first point is the center of the curvature. Yung pinakagitna, kung buo daw natin, kung bilog, no, yung ating mirror na yan, the center there is that point. Okay, natatawagin nating C later on. We also have now the focus or the focal point. Okay, right here. It is in between the C and the vertex, or that part, or that point in the concave mirror. Okay, so ayan na yung mga letters na yan. So yung kaninang naririnig nyo kay Sir Nick na when the object is placed beyond C, when the object is placed at C, when the object is placed at F. So dito nyo siya makikita ngayon at dito nyo siya ma-appreciate. Alright, so let's start with first one. Kanina yung gamit ni Sir Nick's Candila. This time I'm going to use a pencil as my object. So if the object is placed at C, beyond C, lagpas po sa C, beyond C. So let's try to find out now where our image will be formed, saan nakalocate, anong orientation, size, etc. So that is by drawing rays. Okay, so the first ray is what we call the PF ray. PF stands for, it's actually parallel to the principal axis. So nakita nyo, there is a ray parallel to the principal axis. And then F, because it will reflect, no? It will reflect passing through the focal point or the focus. That is why it is called the FP ray. That's our first ray. Now, the second ray is what we call the FP ray naman. Babalik naman natin. This time, this ray is passing through from the tip of the pen or the pencil. It will pass through our F or focus, and it will be reflected back parallel to the principal axis. That is why it's called the FP ray. So, actually, may pangatlo pang ray, hindi ko na nga i-drawing dyan, and that is what we call the C ray, hindi ko na isinama dyan. The C ray should pass through from the tip of the pencil through the letter C or the center of the curvature. And you will see that there will be one meeting point of these three rays, at yun nga intersection point na yan, yung color green dot na yan. At dyan daw sa intersection point na yan, dapat mag-form ang ating image. Kaya mapansin nyo kanina dun sa video ni Sir Nick, yung kandila parang bumabaliktad, no? Ito yun, class. So nakita nyo dito, class, our image, which is color green, no, this time. Binago ko lang yung mga kulay para at least makita nyo yung difference. So yung object natin kanina, no, ano yung ma-form na image niyan kapag ganyan siya kalayo from the concave mirror? Our image will be formed between C and F. Yun yung sinasabi ni Sir Nick kanina. Between C and F, it is inverted. Paano natin nalaman na inverted? Because the rays, the intersection point of the rays, were formed below the principal axis. So, ibig sabihin, kung sa ilalim ng principal axis siya nabuo yung yung intersection point na yan, yung intersecting rays natin dyan, therefore, baliktad daw po ang image na form natin dyan. At, bukod pa dyan, mas maliit siya. So, nakita nyo naman, comparison with the black pencil, the green pencil is smaller. Therefore, the image is smaller. And lastly, it is real because it is formed in front of the mirror. It is not behind the mirror, so it is a real image. So, yung mga sagot na yan sa images, yan po ang isasagot nyo ngayon dun sa table na yan. So, in other words, ibinibigay ko na sa inyo yung sagot. But you are going to draw. Actually, ODL and MDL students, you are going to draw this rays na pinakita ko sa inyo kanina. So, binibigyan ko na lang kayo ng idea ng sagutan, no? But you are actually going to draw. My students from last year, even MDL students, nagdo-drawing talaga sila ng ray diagramming nito, class. So, if an object is placed beyond C, okay, again, the location of the image will be between C and F. The orientation is inverted, the size is smaller, and the type is real. Alright, moving on. So the next one is when our object is placed at C. So dito naman daw, at C. So this is our object. So gagawin lang ulit natin yung ray diagramming na pinakita ko kanina. The first ray is PF ray. Again, PF ray is parallel to the principal axis, and then will strike back dahil sa reflection passing through the focal point or the focus. At ayan yung ating first ray. And then the second ray, babaliktarin nyo lang. First, it will pass through the F or the focal point, and then will strike back passing parallel to the principal axis. So nakita natin na meron na naman tayo ditong intersection point, at dyan daw, class, mabubuo ang ating image, which is, ayan, kitang-kita naman natin, the image is at C. So kung saan nakalagay yung object natin, doon din po nakalagay ang ating image. Balikan niyo yung video ni Sir ni kanina, ganyan din yan, class. Ipinapakita ko lang siya ngayon in a drawing form. Okay? So it is inverted because the rays are formed below the principal axis. It is the same size. Okay? And it is real. Kanina nga, napaka-specific pa ni Sir Nick, talagang yung distance na in centimeters minimension niya. But here, dito na lang tayo mag-focus sa mga posisyon niya with respect to the center of the curvature, the focal point, and the vertex. So that is our number 2. If the location is at C, the image will be at C pa rin. It is inverted, it is same, it is real. Alright, moving on. What if the object is placed between C and F? So again, this is our object, the black one. We'll do now our ray diagramming. The first ray is PF ray. So first ray is again parallel to the principal axis, passing through the focal point, and that is our first ray. The second ray will be FP ray, passing through the focal point, and then another ray parallel to the principal axis, and then this is now our intersection point, yung green point na yan. Ibig sabihin, dyan po ma-form ang ating image. At kung nakita nyo, napansin nyo, may image kanina ng kandila na lumaki, no? Yung apoy ng kandila, and it is inverted, something like this. So when the object is located between C and F, the image that will be formed is beyond C, lagpas sa C. It is inverted because the intersection point is formed below our principal axis. And it is larger, mas malaki, no? Kumpara sa ating original or sa object. And it is real because the image is formed in front of the mirror. Alright, next one. So, ayan ang sagot natin sa number 3. Again, it is beyond C, inverted, larger, and real. Next one. What if the object is at F? So, at F, the object is at F. Again, mag-drawing po tayo ng PF ray. Ayan. Okay, nasabi ko naman na yan kanina. Ganyan din yung gagawin nyo sa paper nyo, no? I will be providing you with an answer sheet for this one. This time, hindi na ako makapag-draw ng FP ray because yung object nandun sa F. That is why my next ray is the C ray. So it's gonna pass through the center of the curvature point. At nakita nyo naman, walang intersection point. Therefore, there is no image formed. Ayun yung sinasabi ni Sir Nick kanina na walang image na form kapag ang object ay nasa F. Because walang naging intersection point, kitang-kita naman natin sa ating mga rays. Alright, so ang sagot lang natin for number 4, no image is formed. And lastly, sa ating concave mirror, if it is placed between the focal point and the vertex, ano na ngayon ang mangyayari sa ating image if the object is at this point? So the first is the PF ray again. So it will pass through. So we have here an imaginary line that will pass through the F or the focal point. Alright, and then another C ray will be drawn here. Another imaginary line, no? Passing through the C ray. And as you can see, the intersection point is formed behind the mirror, therefore it is virtual. Okay, nasa likod na ng mirror. Yun yung huling pinakita rin ni Sir Nick sa kanyang demonstration kanina. Therefore, the image here is behind the mirror. It is upright, hindi na siya inverted. Kasi nasa ibabaw na ng principal axis ang intersection point natin. Upright or erect, pwede natin sabihin dyan. It is larger and it is virtual. Ibig sabihin ng virtual, it is formed behind the mirror. Alright, yun yung pinakita nga rin ni Sir Nick kanina. And therefore, our answer for number 5 is again, behind the mirror, it is upright, it is larger, and it is virtual. Alright, kanina nagpakita rin siya ng sample ng convex. Now, sa convex, sabi ko nga sa inyo, ang sample natin dyan is yung sa 7-11. So, isang position na lang yung ipapakita ko dito because almost all position magiging halos similar yung effect sa ating image. If the object is placed at F, our focal point right here, no? Ayan ang ating object. So, papakitaan ko lang din kayo how to do array diagramming in this one. So, we have here PF ray. So, again, a ray passing through or parallel through the principal axis. And then, dahil nga PF siya, no, dito siya po ngayon papass through dun sa virtual focus. Virtual focus nandun sa kabila or nasa loob ng mirror, no? And then, we have here naman the FP ray. So the FP ray is passing through the virtual focus again and then parallel to our principal axis. So something like this. Okay, at sa nakikita natin, hindi pa magiging enough yung ating mga intersection point dyan. So I'll be giving you the C ray which is color green, na passing through dun sa ating virtual center of the curvature. And then, ayan, dyan na po ngayon nag-meet ang ating 3 rays. Ayan ang ating intersection point. And so, therefore, kaya pala, no, ang laging tingin natin sa pag tumitingin tayo sa salamin, sa 7-Eleven, mas maliit tayo because the image is always smaller when we are looking at a convex mirror. So, the image is, ayan, it is behind the mirror. It is upright, hindi tayo bumabaliktad dyan. Okay? It is smaller. And it is virtual. It is always smaller kasi nga diverging. So, kaya yun yung purpose niya kaya sa mga store nilalagay para mas wide yung nakikita. No? Pero mas maliit, but it's wider. Alright. So, isang sample lang yan ng convex mirror natin because kahit saan nyo halos ilagay ang ating object yan will have the same effect on the image. Alright. And so, hindi na po ako, dahil overtime na rin, magkuquiz kasi nga meron pa naman tayong week 2 next week for lenses. And so therefore, i-discuss ko lang ng mabilis yung ating activity for this week. Naka-open na po to. Yung images in plane mirror, nasa activity sheet to ulit. Yung katulad nga na sinasabi kanina, you're just gonna stand in front of a plane mirror. Meron naman kayong plane mirror sa bahay. You're just gonna raise your hand and so on and describe what you observe. And then for number 2, we have the Who Wants to be a Millionaire. So dito, kailangan nyo lang ng 2 plane mirror and a coin. Kaya siya wants to be a millionaire kasi mapaparami nyo yung coin sa pamamagitan lang ng pag-change nyo ng angle ng 2 plane mirror. Okay, may formula doon. Let us just PM, no? Para ma-gets natin, para sa mga hindi makakagets. Pero I will not be revealing that yet. And of course, ito nga, yung ating activity na Are You Lost After Reflection? So, kung hindi nyo nasundan, kung hindi nyo alam sagutan yung activity na yun, naka-open na rin, balikan nyo ulit yung video ni Sir Nick. At of course, yung aking discussion nga sa summary, because yan na mismo yun. All you need to do is to draw yung mga rays na yan and to answer yung table natin dyan. Same with, ayan, sa ating mga MDL naman, baka nagulat yung mga MDL, ang dami po nung amin. Pero parehas lang po halos yan ng sa ODL. It's just that mas mukha lang siya marami kasi ang dami pero kapraso lang yung mga tanong, para mga 2 to 3 questions lang siya. So ganun din yan, image in plane mirror, same sa ODL, mirror left right reversal, image in spherical mirror, gagamit kayo dyan ng kutsara I think, and then the ambulance, okay? At saka ito nga, yung learning task 5, 6, 7, 8, pinalitan ko na ng Are You Lost After Reflection, yung diniscuss natin kanina, para hindi na kayo masyadong maraming gagawin kasi ganyan din naman yan, paulit-ulit lang. Yung, pag tinignan nyo yung module nyo na learning task 5, 6, 7, 8, yun pa rin yun, ito pa rin yun, pinagsama-sama ko lang sa isang activity na Are You Lost After Reflection. Alright, and so with that, kita-kita tayo ulit next week. Meron bang katanungan? Pumapalakpak lang sila, napakaganda kasi ng video natin for this afternoon. Ayan, so next week ay patungkol naman sa lenses ang ating pag-aaralan. So kung nag-iisip kayo ngayon ng mga applications, week 8 naman po yung applications natin ng mirrors and lenses. Alright? So kung wala na po kayong tanong, alam ko na hindi masyadong madadali ang ating activities for this week. You can just PM your teachers and we will just be answering your queries through PM. Alright? So kung wala na pong katanungan, again, thank you so much, Sir Nick, for the very good video lesson for this afternoon. And see you again next week, only here at Science Matters, where learning never stops. Bye-bye!